Hello students, today you will learn function. For that, let's start with the example. Consider any two non-empty sets A and B and relation R from set A to set B. Let's check following two properties in the given relation R. Property 1, each element of set A is associated with an element of set B. Property 2, no elements of set A is associated with more than one element of set B. Let's discuss these two properties one by one with the help of examples. Property 1, it says each element of set A is associated with an element of set B. First relation R in the arrow diagram here. Each element of set A, they are 1, 2, 3. They are associated with an element of set B. That is, 1 is associated to 3, 2 to 4, 3 to 5. So the first property is satisfied. The first property can also be expressed in another words. No elements in first set A is left over, which is not associated with an element of second set B. That is, there is no elements left over in set A which has no elements associated to set B. In this one, the property 1 is satisfied. In another relation R, in another example, this element 3 of set A has no elements, no second components in set B. 3 is not associated with any of the elements in set B. So the first property not satisfied by this relation R. Third example, each element of set A, it is telling, that is 1, 2, and 3, they associated with elements in set B, 1 with 3, 2 with 3, and 3 with 4. So property 1 is satisfied. One more example. In this one also, the element 3 of set A is not associated with any of the elements in set B. So this 3 is left over, which has no second component in set B. So the property 1 is not satisfied by this relation. Now another property, number 2. It says no element of set A is associated with more than one element of B. In other words, each element of set A is associated with only one element of set B. First example, represented in arrow diagram here. Each element of set A is associated with only one element of set B. So the property 2 is satisfied. Another example of the relation R. It is telling that, property 2 is telling that no element of set A is associated with more than one element of set B. That is, more than one element in set B is not allowed, but one has more than one element here. Also, 4 has more than one element, that is 2. 4 is associated to 2 as well as minus 2. So 2 elements more than 1, which is not allowed. So property 2 is not satisfied by this relation R. Another example, 1 second component 1 minus 1 has second component 1. 2, 4, minus 2, 4. In this one, each element of set A is associated with only one element of set B. The element in B is repeated, but it is associated with only one element here. Minus 1 also has only one element. 2 also has only one element, 4, and minus 2 also has only one element, 4 in set B. So property 2 is satisfied by this relation R. Another example, each element of set A is associated with only one element of set B. That is, there is no element existing in set A which is associated with more than one element. So the property 2 is satisfied by this relation R. And last example for this property here, in this relation R, 3 has more than one element. That is, 3 is associated to more than one element, that is two elements, which is not allowed because the statement is telling that no element of set A is associated with more than one element, but it is associating with two elements here. So property 2 is not satisfied by this relation R. One more example. Consider two non-empty sets, A, X, Y, Z elements, and B has the elements A, B, C, D. Then we have A cross B, the order pairs XA, XB, and so on. Let's take the subset of A cross B, R1. We know that relation is subset of A cross B. So let's make few subsets, R1, R2, R3, R4. Here, these four, R1, R2, R3, R4 are subsets of A cross B, or these four, R1, R2, R3, R4 are relation from set A to set B. Now, let us find out those relations from set A to B which satisfy following two properties. Both of the properties. One property is here, each element of set A is associated with an element of set B. Property 2, no element of set A is associated with more than one element of set B. Here we have to find the relations which satisfy both of these properties. Any relation satisfying both of these properties is called a function. Relation satisfying both of these properties is called a function. So let's check which of them are functions. Now, given relations R1, R2, R3, R4 in arrow diagram, R1 first, it has its order pairs XA, YB, ZC, representing it in an arrow diagram. X is associated with element A in set B, Y with B, and Z with C. Here, each and every element of set A is associated to an element in set B. There is no leftover in set A. There is no elements left over in set A which has no elements associated with set B. So the first property is satisfied. Also, each element is associated to an element of set B. That is, no elements is there in set A which has more than two elements associated in set B. So both properties satisfied, it is a function. Another relation R2, the order pairs are XA, YA, ZA. arrow diagram is here. Here also, each element of set A is associated with an element of set B. There is no leftover element in set A which is not associated to element of set B. So the first property is satisfied. Also, there exists no element in set A which is associated to more than one element in set B. Here also both properties satisfied, so it is a function. Third relation, R3. The elements XA, XB, YC and ZD. Arrow diagram is here. In this one, each element of set A is associated to element of set B. The first property is satisfied. But here, X is associated to more than one element in set B, which is not allowed. The property 2 is not satisfied here. Once again, I repeat, X is associated to more than one element in set B. So property 2 is not satisfied. Hence, it is not a function. Now, another relation are XB, XC, YC. Arrow diagram is here. In this relation, element Z has no elements associated to element in set B. That is, Z is left over here, which has no elements associated to set B. So the first property is not satisfied. Also, X has two elements in set B. X is associated to more than one element in set B. So property 2 is also not satisfied. Property 1 and property 2 both are not satisfied. So it is not a function. Now let's define function. Let A and B be two non-empty sets. Then a relation from set A to set B is said to be a function if every element of set A is associated with unique element, exactly one element of set B. A function is generally denoted by FGH or capital FGH, phi, etc. If f is a function from set A to set B, it is written as function from set A to set B. Now, another topics, pre-image and image. Let's start with the example. Let f be a function from set A to set B. In the set Bueller form, it is written as f equals to set of all the order pairs such that x belongs to A and y belongs to B. Set A is here and x is its element. Set B is here, y is its element. Or element of set A is represented by x and the function is from set A to set B. An element x of set A is uniquely associated with an element of y. X is called pre-image of y and y is called image of x. Once again, I repeat, this x is pre-image of y and this y is image of x. We can also write fx equals to y. This x is pre-image, y is image, and this whole fx is also image because y equals to fx. Once again, let's take example. Set A, 1, 2, 3, its element. B has its element 3, 4, 6. Function is from set A to B and order pairs of f or elements of function f are 1, 3, 2, 4, 3, 6. Representing this function f in an arrow diagram, we have set A and B here. Function is from set A to B, representing these order pairs with an arrow 1, 3, 2, 4, 3, 6. 3, 4, 6, the image, 1, 2, 3, the pre-image. Here, 3, 4, 6 are images of 1, 2, 3 respectively. And 1, 2, 3 are pre-images of 3, 4, 6 respectively. 1, 2, 3 are pre-images of 3, 4, 6 respectively. Here, 1 is pre-image of 3 and 3 is pre-image of 1. It can also be written as 1 is pre-image of 3, or we can also write f1 equals to 3. That is, 3 is image of 1. 2 is pre-image of 4. This 2 is pre-image of 4 and 4 is image of 2. Also, it can be written as 2 is pre-image of 4 or 4 is image of 2. F2 equals to 4. And 3 is pre-image of 6 and 6 is image of 3. Can be written as 3 is pre-image of 6 and 6 is image of 3. Also, it can be written as FA equals to 3, 4, 6 or FA equals to set of all y equals to fx such that x belongs to A and y belongs to B. So it is also written as function is this x is pre-image of y, fx is image, it can be written as y is image of x and x is pre-image of y. Now let's define domain, codomain and range of a function. Let's take an example. Set A, the elements 1, 4, 9. Set B, the elements 1, 2, 3, 4, 5, 6. The function f or the order pairs 1, 1, 4, 2, 9, 3. Representing it in an arrow diagrams. The function from set A to B, set A, set B, representing the order pairs with an arrow 1, 1, 4, 2, 9, 3. Domain. The set of pre-images of a function is called domain of a function. In F, set A is the domain. Also, we can say that set of all the first components of the function is domain, which is 1, 4, 9 here. Now codomain. Set B is called codomain of function f. Set B all. Codomain equals to set B. Elements are 1, 2, 3, 4, 5, 6. Range. Set of all the images of a function is called the range of the function. Set of all images, that is image of 1 is 1, image of 4 is 2, image of 9 is 3. Set of all images, that is 1, 2, 3 in this arrow diagram is the range of the function f. So set of all images is called range. So here range is 1, 2, 3. Also we can tell set of all the second components of the order pair of the function f is range. Here domain, the set which has the elements 1, 4, 9. The elements of codomain are 1, 2, 3, 4, 5, 6. Elements of range are 1, 2, 3. Here we note that the range of a function is a subset of codomain. Let's see one more example. Observe the given mapping diagram and find domain, codomain and range of f. Also write image of 1 and pre-image of 4. Here, domain of f is set of all the pre-images, that is the set with the element 1, 2, 3, 4. Codomain of f is set B itself. The elements are 3, 4, 5, 6, 7. Range of f, it is set of all pre-images, that is 4, 5 and 7. Image of 1 is 4 and pre-image of 4. 4 has two pre-images. Pre-image of 4, they are 1 and 2. Now some important facts about a function. Let f be a function from set A to set B. Fact number 1, the image of x is represented by fx. Number 2, every element of set A is uniquely associated with an element of set B. That is, no element of set A has more than one image. Number 3, one or more element of set A may have same image in set B. 4, some elements of set B may not have pre-image in set A. Number 5, the range of a function is always the subset of codomain of the function. Maybe it is proper subset, maybe improper, but range of a function is subset of codomain. Okay, students, this much for today. Thank you.